Good afternoon. Thank you both for joining the AWS studio.
Good afternoon.
Let's jump right in with a few intros, starting with you, Nahum, and then over to you, Zeb.
I'm Nahum. I work in Swisscom as a senior DevOps engineer, and I'm researching the 5G core in the public cloud in AWS.
Okay, I'm Zeb Khan. I work in EC2 product management team. So in that team, we work with customers who have workloads that cannot be completely run in the region. So they need to be run in local zone and outpost for latency or data sovereignty purposes. And my focus is particularly on telco workloads, specifically packet core and IMS.
Let's unpack why we're here today. We're here to talk about building cloud-native mobile cores on AWS. So let's start with you, Nahum. As you think about the design principles for building that cloud-native mobile core, what comes to mind? What are you thinking about, and what were your customers telling you?
Actually, the important thing is to shift the focus from monolithic architecture to a microservice-based architecture. So doing this and shifting the focus on microservices architecture allows us to be more flexible and having the different tools, different workloads run in many different ways, and in this case on containers.
And so from your perspective, Zeb, this is something you focus on all day long. How is this emblematic of your overall strategy of empowering telco operators to build these cloud-native solutions?
So customers like Swisscom and feedback that we also get from other customers is that they want to shift their focus from managing network functions to managing customer experiences. So from that perspective, it's very important for customers to improve their time to market, improve the overall aspect related to the maintenance of their 5G core. So activities such as upgrades and updates that, in prior generation used to take a significant amount of effort, so including human resources. And these efforts used to be very capex intensive. So that sort of limit the level of innovation and the pace at which our CSPs could iteratively build new experiences and launch those experiences without dedicating capex and resources. So they want to get away from that model, and microservices is sort of like the vehicle for using that model so that they can have much fine granular control of the life cycle of the network function. They can eliminate undifferentiated heavy lifting related to running these workloads. So for example, if there are aspects such as managing control plane of Kubernetes, or if there are aspects related to getting storage as a managed service, if those aspects can be managed by AWS, then our customers can focus on creating new services. And just a couple of more things I remember, feedback I received from customers is also that they want an architecture that is portable across, AWS Cloud Continuum. So for them, it doesn't matter that which location and for which use case they're deploying the use case. They want an architecture that allow them to select any arbitrary location based on the use case. So if it's one of AWS 31 regions or 32 local zones, or even outpost on-prem, they want the architecture to be consistent and same across the cloud continuum, so that they don't have to manage different infrastructure stacks for different use cases.
So it's not just location agnostic, it's topology agnostic that what customers were asking for across this range of cloud continuum solutions. That's great. Maybe let's talk a little bit about the strategy from an operational perspective. How do we work with our customers, the likes of Swisscom, to help develop these solutions? What does that process look like? The collaboration, engineer to engineer. Take us behind the scenes.
Sure. So there are a couple of key aspects. One is that 5G core is, or in general, packet core is very complex, workload, which is basically provided by different ISVs, and different customers have, and even for different network functions within packet core, choose to go with different ISVs for various reasons. Now, so one of the most important things that we do as collaboration with customers like Swisscom is that we collaborate with their key ISVs and we help their ISPs to actually adopt, the cloud-native design principles, so that in turn they can, offload a lot of undifferentiated heavy lifting that they have to do, so that their stack and their network functions are portable and can be deployed and managed at scale with rapid innovation. So one example I can give you is like previously, if ISPs used to design their own front-end load balancers, or if they had their own solution for replicating data for high availability, they don't have to anymore with like, let's say, AWS auto scaling, AWS managed load balancers. In EBS we have utilities where you can create like volume snapshots and put them across different regions. You can have lifecycle policies for S3 to manage where you want to keep your data. So with all of these capabilities provided as managed service, even our ISVs in Packet Core ecosystem can focus more on providing the features that matters to customer like Swisscom, so that they can launch new products and services.
Indeed, will it switch to the microservice architecture on having smaller building blocks? What we aim as well is to have more frequent deployments in the network. So basically, as Zeb said before, if we envision constant improvement and constant deployment of the new features, we can be faster to give our customers what they want, that these new features and have readily available in our network services that they can use and enjoy. And at the end, it's all about that, about creating value for our customers, shifting the focus from building NFs, from building nodes, and to building services.
So let's start talking a little bit more about the deployment. What exactly did you build, and how was it architected in a cloud-native way? And maybe even on top of that, were there particular features of AWS that were particularly attractive in selecting the cloud as the right deployment method for this solution?
Yes, indeed. What we focused on a first place, it was automation. So we are building the whole 5G core, not aiming to have working features or being having the latest thing deployed, but having a structure, an architecture, and something that can be entirely automated from end to end. So from that point of view, we have been using different AWS services. The code suite, for example, so we use code build and code pipeline to automate end to end. So from one-click deployment from our internal pipelines, we can trigger as well the 5G core installation from the VPC to the network function, and as well applying the day one config. We tie this all together as well with step functions and Lambda to have more granular control of what we have, and also control the process end to end. And as Zeb said before, if we are using AKS, we are shifting our focus from having to upgrade platform, having to do this heavy lifting, or being worried about the maintenance of the infrastructure, and again focus on automating our core network, but from a point of view of the service perspective and not the network front ends.
Maybe for you, Zeb, I feel like many don't always appreciate the rapid pace of innovation that our customers can have in using solutions like EKS, S3, EBS, all the solutions and services you just mentioned to architect these highly complex, geo-distributed, cloud-native solutions. What's one thing that you wish people knew about some of the ways that we've been able to make our customers' lives easier in deploying, but also managing these solutions?
Yeah, that's a great question. So if I take a step back, in previous G, 4G, 3G, 2G, my role was actually, to do deployment and upgrade of, these systems. Now that involved writing 100+ pages long documents that involved, testing the procedures, that involved, preparing yourself to do rollback. And we are talking about, in most of the cases, national infrastructure that not only allows you to, browse the internet, but that also serves the purpose of emergency calling, lawful intercept, for example, right? So if one thing that, is going to be very essential, like, Nahum said, is not that, you have the best infrastructure available to deploy 5G core. Reliability of infrastructure is very important, but it needs to be combined with the agility to perform operations, and to perform operations in a manner where it's not, it doesn't sound scary, to have much fine granular control of, what operation you want to perform, ability to introduce, new features. So for example, like, and I know like there have been established, and standardized processes in the telco industry because, a lot of aspects of telco, even automation, is stipulated by standards written by 3GPP, for example. And, we want to make sure that we make it super simple for customers like Swisscom, the overall experience of not just onboarding their network functions, but also running it at scale in an automated fashion. Like last week, we announced, a product called the Network Builder. And the main reason for the Network Builder, provided as a managed service is that customers can bring their own, familiar tools like, writing the intent of what you want to deploy in Tosca, or, bringing in packages in which applications are encapsulated as, Caesar. And let us do the undifferentiated heavy lifting of, basically generating CloudFormation templates and, take that intent and deploy the infrastructure. So it becomes, part of, or, like a natural part of creating experiences rather than, focusing just on, well, I have to deploy these 12 network functions, how I'm going to deploy them.
I'm really glad you brought up Telco Network Builder, new service we announced. Great blog by Jeff Barr that was released. Highly encourage everyone to take a look at that. But there's one thing I'm taking away from what you just said. It doesn't have to be scary. I think that's really important. As you build that mobile core in a cloud-native way, the automation and all of these managed AWS services makes the developers' lives easier. So they don't have to reverse engineer services, as you mentioned, leverage best-in-class tools so they can focus on value differentiating business activities. So tell me about that building journey. What AWS services did you use, and what were some of the benefits and things that you may have had to traditionally manage in the past that now were managed for you?
Basically, as I said before, besides the code suite and the pipelines, using EKS, for example, simplified our deployments on this case for not having to manage the Kubernetes layer and worry only about the containers. Also, we by using ECR, for example, we can get our containers analyzed for security. That is also an important point that we have. So the security end-to-end, having AWS services that help us manage, audit, and enforce security policies from end-to-end is also great. For example, Control Tower, we can enforce guardrails and enforce network policies, security policies, and control what is really happening in our network, what we allow end-to-end connections and deployments.
From a roadmap perspective, what's next? What additional capabilities are you looking for?
Well, we actually are looking forward to have an end-to-end orchestration from all types of workloads that we can use on our internal platforms and also in AWS, for example. And as well, it would be great to see some telco-specific concerns, protocols, and operations ported and seen in AWS.
And Zeb, is that what you're hearing from customers more broadly? Feedback similar to Nahum?
No, yeah, absolutely. So, security has been very important to our customers, and it's very important to AWS as well. So, there is an aspect of security off the cloud, where we have our Nitro system, which is a collection of specifically designed, cards for offloading certain aspects of virtualization like storage, networking, control, and a thin layer of hypervisor and a security chip. So basically, as a system, what it provides is first of all, to begin with, the host on which the instances run, powering the 5G core workloads. Those are separate from the custom designed cards where virtualization functions run. So that provides a physical isolation. In addition to physical isolation, they're also logically isolated because there is no operator access, for example, between those components. So there is no SSH access. The only way we can talk to those parts of the Nitro component is using very hardened, secure, encrypted, authorized, authenticated set of APIs. So the reason why I mentioned that is that it allows us to control the virtualization stack with imperceptible impact on customers' workloads. And that's very important for 5G core network functions. And it also improves overall security posture off the cloud, because as a result of the Nitro security chip and Nitro controller, the first code that goes in any target system, which is the a bootloader, it actually goes through a series of measurements, and it gets cryptographically verified using hardware root of trust before the system even comes online with the software in which you can run instances. And that adds to the trust and the confidence that 5G core customers look at when they are running workloads, again, where they'll have 911 or LI and these type of functions running. So that's one thing which customers find very important and they appreciate. As far as the roadmap aspect is concerned, so we launched, for example, direct connect to local zones for workloads that require low latency, like UPF, part of 5G core last year. We announced, in last reInvent instances in the region that can support up to 200 Gbps of throughput, right? So if, let's say, there are customers who want to scale their UPF horizontally, where they're looking for good CPU to throughput ratio for again data intensive or UPF workloads, they don't have to increase the number of instances anymore. We have introduced features in EC2 and EKS related to networking to improve resiliency of core workloads. So, for example, EKS introduced local clusters where you can also run master node, on outpost. So if there is, let's say, fiber cut type of a situation in on-prem, it can still sustain that type of, event, because the master nodes of Kubernetes are running as a result of this feature on outpost. And, again, there are features like, for example, spread placement on outposts where, again, it improves 5G core workloads resiliency, because you can spread an instance running, or instead of instances running 5G core workloads across multiple hosts within the same rack. So there are, we are working with Swisscom and other customers to come up with capabilities with which they can see more and more functions provided as managed service, so that, or as undifferentiated heavy lifting eliminated from their stack and from ISV stacks. And that's what we'll continue to innovate on.
Well said. Simply put, the breadth and depth of services, we believe, positions us as the cloud provider of choice for mobile core workloads. And perhaps, Nahum, from your perspective, moving away from just the technology impact and looking at the business impact, through this architecture or re-architecture, what business impact are you expecting to achieve for your end customers?
Actually, the thing that we value the most about this is the freedom that our engineers and our teams have to try new things. So before we wanted to try a new technology, new product, or new service, there was a lot of things going behind the scenes until this platform was installed, prepared, and approved. Today, we can just have one engineer spinning some AKS cluster and try new things, developing things without all this hassle. And what we see as a business value is that we can focus on innovating and on creating new things, improving our way of doing operations, improving the way we do things, and trying to create value-added services for our customers, which is at the end the most important thing for us, create value for our customers.
So maybe as we look to the future, what's the next level of cloud-native mobile cores in the cloud?
Well, one can dream. If I envision as a network that is, from the point of view of operations, fully automated from end to end, that can react to events, and we can shift the focus from reactive maintenance and looking at alarms and react from proactive by leveraging big data analytics to analyze the behavior of the network and react to the changes before we even see any impact in production in the end customers, for example.
What's your vision, Zeb?
No, yeah, I completely agree with Nahum. Just one point I want to add to that is that there is another aspect that for telco workloads was very hard to achieve in past Gs, and customer expect that we would actually innovate and provide simple solution to that problem as well, and that's their sustainability goals. So we have actually added another pillar to a well-architected framework, which is the sustainability pillar. And as a solution architect, if I don't help customer design solutions that meet their sustainability goals, I'm not doing my job as an SA, right? So there are tools, for example, customer carbon footprint tool with which customers can see what's their contribution to the carbon footprint. There are guidelines and principles, like, for example, using auto-scaling or using life cycle policies for S3 to actually, meet the target goals pertaining to sustainability, even for telco workloads. So we have actually customers like, for example, entity Docomo that, worked with AWS and NEC to run 5G core trial on Graviton 2. And they observed up to 72% of improvement in power consumption versus, like-to-like, x86 instances running that 5G core workload. So sustainability, I would say, is another, key aspect.
Fascinating discussion here today. Really appreciate the technical depth and rigor that we had in this discussion. Appreciate you sharing your insights, and thanks again for stopping by the AWS studio.
Thank you.
Thank you very much. Thanks, Nahum.
Thank you, Seb.